In today's video, we'll be looking at a time series downloaded from the National UFO Reporting Center, or NUFORC. This time series tracks the number of monthly reported UFO sightings reported to NUFORC. We start the time series in January 1990 and end it in July 2021. This dataset is comprised of a heterogeneous mix of reports. We can partition them in different ways. First, was the reported experience tangible or intangible? Now, by tangible, I mean something that was actually physically in the sky, something that we observed, but it was actually there. Whereas intangible would refer to, well, hallucinations or just pure BS reports. Of the tangible reports, many will probably be caused by mundane phenomenon like weird-shaped drones or satellites. The remainder are the extraordinary phenomena, which could be terrestrial, like, say, a top-secret spy plane, or beyond terrestrial, like aliens or time travelers. What can we learn from this heterogeneous mix of unexplained reports? Let's look at the data and find out. When analyzing time series data, we typically are looking for three things. The first is an overall trend in the data. Is my data increasing? Is it decreasing over time? What's it doing? The second is seasonality or a cyclic behavior. It's very common to find periodic patterns in time series, like, say, annual cycles in climate data. The third is the noise term. The noise term is going to be a stationary stochastic process which tracks the local fluctuations of the time series. So let's look at this NUFORC time series on both the absolute scale and the logarithmic scale. There are three things that we can see right away, and that's that, one, there's definitely a non-zero trend in the data. There also appear to be annual fluctuations in the series, and the variance, the up and down fluctuations, vary a lot in magnitude as we go across time. This means that we have a non-stationary, heteroscedastic time series with seasonality. How are we going to handle this? Such analysis is very exploratory. That is, you gotta try a lot of different models and see what works. And behind the scenes, that's exactly what I did. Now, after some trying different models, the best way I found to look at this data was to start with a change point model. A change point model assumes that we locally have a stationary homoscedastic time series, but the mean and the variance can just change to new values at certain time points, and these are key. The change points are what we're looking for. The task at hand is to identify these change points, and as an example that fits this paradigm, we could consider, say, foreign exchange rates. On a day-to-day basis, the US and Canadian exchange rate remains about the same, up to some minor fluctuations, a little bit of noise in the system. But given some economic shock, the exchange rate may begin to drift quickly to a new equilibrium point. When we apply change point analysis to the NUFORC data, what we find are 10 different time periods using what's called the PELT method, which stands for Pruned Exact Linear Time. More details on this methodology can be found in the R package documentation for change point. There's no one right way to identify change point, and there are other algorithms out there, but this method gives us certain times in the last 30 years to investigate, so let's do that. Our 30-plus years of UFO reports has been broken into 10 subintervals. First, we have 1990 through 1994, a 5-year span where the average number of monthly reports was only about 33. This suddenly changes in January 1995. The number of reports more than triples to 112 per month, and stays that way until April 1998. There is a big increase to 194 reports per month. This lasts for 1 year. That's then followed by another increase to 294 per month, which stays steady for just over 4 years. May 2003 comes around and the number of reported cases jumps again to about 400 per month, which continues for the next 8 years. Now it's May 2011 and we jump again to our highest point, 659 UFO reports per month, which stays like this for about 4.5 years. It's now October 2015 and the number of monthly reports starts to drop. First, we drop down to 451 per month from October 2015 to November 2017. Then we drop again to just under 300 reports, which goes from November 2017 to March 2019. Then we skyrocket to 625 per month, which goes until October 2020, at which point we plummet again to 276 per month. And that takes us right to, well, today, or technically speaking, July 2021, because that's where I cut the data set off. All right, so that was quite the roller coaster ride, but what does it mean? There's a steady increase from 1990 until about 2003, which very well could be attributed to the spread of the internet across the US and Canada, where most of these reports are originating from. According to Wikipedia, NUFORC has had a 24-hour hotline since the 1970s, but I have to assume that most people were just not aware of that number. In contrast, today you can do a quick internet search like, how to report a UFO. Interesting side note, Google that question, and what you find is SETI, the FAA, and lots of mainstream media websites. In contrast, I tried using DuckDuckGo with the exact same question, and it immediately leads me to NUFORC, and secondly, a website called UFOs NW, NW being Northwest, and they focus on the Pacific Northwest. Probably I got that result because I'm sitting in Edmonton right now. Anyway, 1994 was also when Peter Davenport took over as NUFORC director, so perhaps there was a change in reporting methods as well. I don't know the history of the organization beyond what I could find on their website and Wikipedia. Of note, there's no change in the reporting pre- and post-9/11 attacks, which I thought was quite interesting because one could assume that an airplane-based terror attack would lead more people to, one, watch the skies, and two, watch the skies in fear, looking for things, but this doesn't appear to be the case. The big change point in 2003 coincides with the start of the US invasion of Iraq, and if that start of that war meant more military aircraft and drones flying around the US base to base and whatnot, then there may be a causal link there. The 2011 jump was massive. If anyone has a good theory, please leave it in the comments below. The best I can tell from a quick internet search is that there was a reported sighting of a UFO in Jerusalem, which may or may not have been a hoax, but Jerusalem being the most scrutinized city, arguably in the entire world, and the focal point of many major religions, it seems reasonable that something like this could have caused a jump in reports. The last big jump of interest happened between March 2019 and October 2020. What I love about this spike is that it happened pre-COVID pandemic. If the spike were to have occurred simultaneously with the pandemic, then I'd have to assume it was because, well, one, people's behavior changed radically during lockdowns, and two, there was a general air of fear regarding a mysterious, unknown virus spreading from Wuhan around the world. In contrast, the spike actually began early in 2019. Why did this happen? I have no idea. If anyone has a good idea, please leave a comment. I would love to read them. As an alternative approach to studying change points in the NUFORC time series, I went to Google Trends and typed in UFO to see how frequently people in the US are searching for UFOs. The idea behind this is that if there is heightened interest in UFOs, then there may be just more people watching the skies and reporting what they see, whether it's mundane or extraordinary. This time series runs from 2004 to the present day, and is also interesting as it appears to be, well, just a bunch of background noise, and then the occasional big spike for 1 month that then just vanishes. What this says to me is that the general public has a toddler-like attention span when it comes to UFOs. Basically, something happens. Everyone Googles it for about, say, a month, and then everyone stops caring and stops Googling it, until, of course, the next big story comes along, and then we repeat the cycle. Regardless of the reason for this spiky pattern, the top 10 biggest spikes in the Google Trends time series occur on April 2004, January 2008, 3 quick spikes in June, September 2010, and February 2011, October 2015, November 2017, March 2020, when COVID took off and lockdowns began, and lastly, a 2-month spike of April and May 2021. What's really cool is that the Google Trend spikes in October 2015 and November 2017 precisely correspond with change points we found in the New Fork time series. Furthermore, 2017 coincides with the release of the now famous videos from the USS Nimitz and Theodore Roosevelt. But there's something odd about this. Google Trends tells us that UFO internet searches went up drastically in these 2 months, but the average number of New Fork reports, monthly reports, dropped from 659 to 451 to 299. You'd think if people suddenly were interested in UFOs and there were some cool videos coming out in the media that it would correspond to an increase in monthly reports. But it doesn't, it decreases, and that confuses me. We can identify all of the Google Trend spikes on the New Fork time series, which looks quite fascinating, but again, it still baffles me. So again, I ask, dear YouTube viewer, let me know if you have any good ideas as to the patterns in this data. Okay, so that's enough for change points right now. After we account for all of these change points, what remains? Well, we can center and scale the time series based on means and variances found by the PELT method. What remains is a mean zero homoscedastic stationary time series, hence we can try fitting an ARMA model to this time series. What we get is an AR1 process with parameter 0.277 and a seasonal AR2 process with parameters 0.25 and 0.24 with a period of 12 months. What that means is that there's a strong temporal dependence in the noise process underlying the New Fork time series. The AR1, the autoregressive process, tells us that the number of reports from the previous month are positively correlated with reports from the current month. The seasonal AR2 model tells us that there's a strong 12-month periodic pattern in the time series, with influence stretching back into the 2 previous years. This can first be seen clearly by looking at the original time series. However, we can also translate into the spectral domain, where the smoothed periodogram, using a smoothed periodogram, which will tell us which frequencies are most prominent in the time series. The only frequency that really stands out is precisely the 12-month one, or the 1-year annual cycle. If we average over all of the years, further inspection shows peaks in the summer and fewer reports in the winter. Now, I normalized each of these averages by the number of days per month, since, just thinking about it, there are fewer days in February to report or to even look for a UFO than there are in March. The plot of the normalized averages indicates low numbers of reports in December through May and higher numbers of reports in June through November. The best month for UFO reports is July, and this is presumably because the weather is nice. More people spend more time outside. Also, most of the reports in New Fork are from North America, so it makes sense that the summer months in the Northern Hemisphere would be the prime times. Though, November is still a more popular month for reporting than, say, May, which seems odd to me. Nevertheless, it would be fascinating to see if such data from, say, Australia would have the reverse pattern. I'm looking at you, Ross Clothart. What have we learned from this time series? Well, first, we have a really nice example of a time series with change point behavior and seasonality. Why are these change points exactly where they are? I don't know. We can try to take guesses based on certain world events, but it's worth noting that statistically, these change points I found in my analysis may be off by a month or two. Remember, statistics is not an exact science. We're wading through the noise here. So even though a change point may happen on a given month, it actually may have occurred, plus or minus a month or two. Nevertheless, some change points do roughly coincide with spikes in the Google Trends series. Also, why was there a big increase in reports 9 months before COVID became a thing? Now, I'm not saying conspiracy theory, but it would have made a lot more sense in my mind if the change point had occurred in March 2020, along with the Google Trends spike, rather than in March 2019. Now, this is just part 1 of my investigation into the New Fork time series. Stay tuned for part 2, where I try to find other time series of data that can be used for predicting the number of UFOs reported monthly to New Fork. And as a quick end note, if you want to learn more about time series methods, I've put some links in the description to my lecture videos on my other channel that discuss topics like ARMA models, seasonal patterns, and working with the periodogram in the frequency domain. Now, they are long and they're a bit dry, but they're there if you're interested in learning a bit more. I never did a lecture on change point analysis, as it was beyond the scope of the course I was teaching. However, it's a really cool topic, so I may have to record a bonus lecture once I find the time. Lastly, I uploaded the New Fork time series and Google Trends time series to my website with links in the description in case you want to try to analyze it yourself. It's a really cool time series to look at, regardless of if you like UFOs or not, so check it out. And thanks for watching. I'll see you in the next video.